Hello and welcome to this first lecture on experimentation in this course on how to become a data scientist. So in this section of 7 lectures, we will talk to you about how can you learn about experimentation to become a successful data scientist. And we will begin in this lecture to talk about how to design and execute experiments, design as well as execute experiments to test your hypothesis and measure the impact of the various interventions, either as a result of your data analytics or actually in real life when you start implementing the recommendations. So, any thoughts on how to design and execute experiments? Anything that you know you'd like to share now? Right. So, designing and executing experiments to test hypotheses and measure the impact of various interventions involves a systematic approach. It's a systematic approach that is necessary to ensure meaningful results. And what that systematic approach is, let's take a look at a guide on how to plan and conduct experiments effectively. Right? Ready? Great. So, you need to begin by clearly articulating the objectives of your experiments. And in that, two basic questions you need to answer. What specific hypothesis are you testing? What is it that you want to find to be true? That is your specific hypothesis. And what outcomes are you looking to measure? What are the outputs or what are the outputs or what are the end results that you want to measure? And based on that, you define the success criteria of your data analytics project, data science project, right? So two key questions that will define your clear objective. Then you need to formulate the hypothesis. So develop clear and testable hypothesis that aligns with your objective. Clearly state the null hypothesis, H sub O, HO, as you see here. Supposing you want to prove that the mean of the population is 3.0. You find the data that says mean of the population is 3.0 and you want to test it. So you will set your null hypothesis as mean of the population is 3. And alternate hypothesis H1 will be something that is not true as H0, which could be mean of the population is greater than 3.0. And in this H0, there could be another example that in a generic association study, there is no association between disease state and genotypes of a particular SNP. And the alternate could be that there is an association. So this is how you formulate the hypothesis. Then you choose an experiment design. Select the appropriate experimental design based on your goals, and that requires you to do two things: randomized control trial, two ways, and quasi-experimental design. So you could choose either of them to, between the two, you could choose what is appropriate for you. In randomly controlled trials, you randomly assign data to control and the treatment groups. So the data is randomly assigned. So you have two groups, control group and treatment group. Control group or experimental group. Control group is where you do not change any input variable and life as usual, where experiment or treatment group is where you use the interventions based on your outcomes. So you randomly assign data there. The quasi-experimental design, if the random design is not feasible, you use methods like matching or statistical control to do a quasi-experimental design selection. Then you define the variables and matrices. Clearly define the independent variables, interventions, the x1s if y is an output, and the dependent variables, the outcomes that you will measure. So y, if your equation is y is equal to a function of x1, x2, x3, then x1, x2, x3 are the interventions or the independent variables, and dependent variable is y, and you clearly define what that y and x1, x2, x3 are. Then you choose the matrices that align with your objective. The x1, x2, x3 and y that you align with your objective, because you want to achieve your objectives with this data science project, don't you? Then you determine the sample size, calculate the required sample size to achieve the sufficient statistical power to ensure that your conclusions are statistically valid, and to ensure that you ensure that your sample size is large enough to detect meaningful effects. And there are statistically proven methods by which you can determine these sample sizes. Then if you are using a random control group, then you implement randomization to ensure that the data is assigned to treatment and control group in a random and unbiased manner. So using RCT, you need to use randomization basically to make sure your data is randomly assigned to both the groups and in an unbiased manner. And you establish a control group that does not receive the intervention we talked about briefly. So you have two groups, experimental group, let's say an example here. The experiment is effect of a biofertilizer X on plant growth. So control group is where biofertilizer X is not sprayed on the right hand side. Then experimental group is where biofertilizer X is sprayed. This control group provides a baseline for comparison and helps attribute changes to the intervention as we have shown X here. Now, then you collect baseline measurements. That is before making the intervention, pre-test, before implementing the intervention. And follow with a post-test measurement after the intervention to assess the changes. So if you see, your data is split into four quadrants. One is control group and treatment group, and before and after. So you have data on before starting and after starting in control group, after giving the interventions in the treatment group, and you have the data for before and after in the treatment or experimental group also. So having looked at some of the things that can help you do the experimentation, what do we do next? We look at an interesting variable called confounding variables in the next lecture. So we will define what that confounding variable is and how to address the confounding variable to find right and meaningful outcome from your data science project. So thank you so much for watching this first lecture on experimentation in this course on how to become a data scientist. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer your questions, and also download the PDF file to take a look at anything that we have talked that you need to look at.